All right, so I'm getting it reassembled now. It slid back in just fine, not that it gets out of the way. And I have the cover, or this, I don't know, plate, bottom plate, whatever you want to call it. Got that back in there. You got to put some silicone, around the perimeter of this before you slap it back in there. That way the lead and the dust on it just doesn't leak out. Now that peg goes through this guy right here. It's not completely assembled. I still gotta align it. It has to go through this dude right here, and I can make tweaking adjustments to it to where you can see a distance right here, and on this other side about the same. Earlier I was talking about the importance of getting your three-phase correctly, get it wired in correct in order for the auger to be spinning in the right direction. It's kind of what the brains looks like. Now when they do an install, they're not going to put in these PAM, this is called a PAM 1 relay right here, 120 volts or 24 volt AC. And what I'm doing, I'm supervising power to each of the legs. So you can see I got this guy labeled as the horizontal motor. It's a vertical motor. So you have black, red, blue coming in from a breaker. Okay, coming from the breaker. And so power comes in. This is your lockout tag out point right here. So you kill the power here. So you got these big power wires coming in from the bottom. Okay, then it translates into a black, translates to a red, translates to a blue, and then gets it distributed. These guys right here gets distributed, and power comes in, flows this way, and then it goes through a switch, and then it flows out to the conduits that feed the actual motor themselves. Okay, it's important here that you have a fire alarm system. Okay, there's different kinds of fire alarm panels and stuff like that, but even if you're using an intelligent panel, where it's a SLC point addressing panel, or if you're using a standard zone panel, it really doesn't matter. So this is coming in. I installed this dude right here. On the other side of that's where I have my monitoring module. I'm using a Firelight 9600 smart panel. So what I did is I said, okay, module on the other side, I want you to be a supervisory module. And what it's looking for a short. If it detects a short, it sends the fire alarm panel into supervisory, and you have your fire alarm company, your monitoring company, say, okay, anytime I see a supervisory on this particular point number, send me a text, send me an email, say auger power problem, trouble, whatever. That way you get notification immediately if for some reason you lose power on one of these legs feeding the motor, whether your motor burns up, and it causes breakers to trip, whatever. If you have a power loss, okay, and it's like, well, how do you monitor power loss? Well, that's what these PAM relays are doing. All right, so if I wanted 24 AC, I'd be using the red, but I want 120 volt AC. So that's white, that's black. So all I'm doing is I'm putting all my neutrals together, okay, and that's coming out to, let's see, where's my neutral? All right, yeah, this guy right here, is this guy right here, common neutral. All right, so you have a 3-leg hot. Okay, so 1, 2, 3, but what I'm doing, because I'm anal retentive, hot 1, 2, 3, 4, 5, 6. Okay, and this guy's its own breaker. That's the timer. It's 7. Okay, so you got 7 hots to deal with. But at the end of the day, if you really wanted to just, I don't know why. I mean, being anal retentive when it comes to this stuff, or it's going to cost you money. I mean, technically, all you have to do is just monitor the first, blue, red, black, some kind of combination. Just monitor, and you can cut down to 3 modules. But don't be anal. I mean, don't Don't be loose with it, you know, just be anal retentive with it. Okay, so each one of these PAMs is monitoring a leg of the hot. So black, red, blue. Okay, for translates to PAM, hot, hot, hot. Black, red, blue, hot, hot, hot. This guy right here, it gets its power. This timer, okay, there's your hot for it. Gets its power, so I'm monitoring that too, because I believe on the inside it's on its own breaker. So the way the logic is, so long as these PAMs are energized, that means power is coming from a breaker. Breaker is not tripped. If a breaker does trip, or if a leg of power goes out, then you lose power on the PAM. When you lose power on the PAM, it internally shorts on the blue and yellow, I believe, shorts, okay? Then the fire alarm wire, see how it's the fire alarm wires coming in, and it's like all these blues are clustered and all these yellows are clustered. I'm not using the orange, okay? So if I lose power on any one of the PAMs, short is detected by the module connected to this wire. Module is connected to SLC, sends a signal back to the panel and says, hey, you got a power loss on your auger. You don't know why you have a power loss, you just got power loss. It could be a breaker that's tripped. Fine. It could be the motor's burnt up. You need to know that early, or else your bill's gonna get a lot bigger if you don't catch this crap early. All right. Now I'm kind of going over that, and I'm assuming that you guys have some type of electrical experience. But I can always make another video or something going into further detail. But just watch this one again, and if I'm not clear, I don't know, it makes sense in my head, but it may not make sense in yours, so it's no problem. That's what communication's for. Okay, so we know that the three-phase hot is wired correctly because, watch. Okay, it's off. So if we go to hand, see, pulling it this way. You want it to pull this way. Pulls this way, and it goes on the uptake of the auger. You can kind of see the lead making its way out. Lead making its way up. Takes time. So it goes up. Once it gets to this point up here, it'll drop down that tube into your lead barrel. Right now I'm just function testing it. Making sure it likes what I did. You can see all that lead coming. You can also see how the ingot would form. If that lead's not allowed to flow into your barrel, and if it stays put in your trough, and your trough auger is turning on lead that isn't moving, well, that lead has a low melting point. And when that lead, it'll just melt together, and start to build up, and then before you know it, you got an ingot. Let me show you. I took it out. That's what the ingot looks like. Kind of reminds me of sandstone. So you can kind of see it's multi-layered, bullets on top of bullets, that's gotten smelted together because of the heat of that blade of the auger just cutting into it. So, of course, we don't want lead to come over here, so this one's spinning opposite direction and forces it back this way. We want lead to come here, collect, and rise up. Now, of course, I haven't fine-tuned it yet. I haven't got this one part on there, but you can kind of see what's going on. See, everything is working like it's supposed to. I don't hear any scraping, screeching, grinding. It's the way it's supposed to sound. This motor has a lot of torque to it. Something binds on it. It's not going to turn the motor off. It's going to snap that peg right there and burn your motor out. Snaps that peg, then it becomes big pain.